grades up right now, this minute. No. All right, so I want to do another Atwood machine question, just like yesterday. And I say I want to. I really don't want to do this anymore because I just find this terribly boring. But I at least like this stuff. When I say terribly boring, it's not because I find this actually to be kind of the way physics should work. I like this kind of stuff. But I've done all this with mechanics already. And so I've sat through a bunch of these. But you guys, this is the first time doing it. So, I'll still treat you with dignity and respect when you get it wrong. And I won't say the things I say to my people in the mechanics class when they get it wrong. Like, this is going to be on the test, man. What's wrong with you? You're going to fail. You're never going to amount to anything in life. Stuff like that. They really don't like it when I say that. All right. Oh, and apparently I'm going to be pied in the face next week.
Woo!
Yeah. It's I never make any money doing it. Like, it's a fundraiser. No, nobody wants to do it because they're scared that there'll be retribution. But it's for that thing still. And it better be what's it called? Shaving cream, yeah. Not whipped cream. I won't do whipped cream.
Why not?
Stinks. It curdles. I mean, within about an hour, it smells like curdled milk the rest of the day. It's not like there's showers here. So you're covered in curdled milk for the rest of the day. It's just awful. I did it once at an NHS meeting, and I swore I would never do it again. Okay, so do you remember these problems? So they're not hard problems now, or shouldn't be. And you should remember how to do them. They involve the Newton's second law and understanding that these two things are connected. And with or without friction, these problems aren't terrible. But if you haven't done Newton's law stuff in a while, it can be tough. I'm going to ask an obvious question that I would ask. If I said that this was massless and we were going back to like first semester stuff, would you be able to figure out the acceleration of this system? Let's prove that. I heard the yes. And, there's 18 of you here right now, 19 of you here right now. All of you should have the same answer. So I'll give you 4 minutes. You're the ones who said yes. And now I'm going to go get rid of some coffee. I'll be right back.
Wait, massless means what's equal to 0. Wait, I took it up on oh yeah,
Wow, our confidence might have been a little too high. What a disappointment. Wow. Wow. So, now you know why I can't trust you guys.
I thought it was rhetorical, like just like you say yes and then
You thought it was rhetorical. That's so cute. No, it's not. You know, look, your AP exam's going to have this stuff plus more. So, yeah. If you want to look at the short answer, net force equals inertia times acceleration. The unbalanced force is 2 mg. The inertia is 5m. So the acceleration is 2/5 g. You know, there are shortcuts here, and I told you we could do shortcuts. If you're careful and you know what you're doing, but look, it's clear you guys don't know what you're doing. Now, writing that down is ridiculous because you don't know what any of it means. You don't know where the 5 came from. Now, you're supposed to start with something like this. You know, free body diagram. And then we even did this yesterday, which is what's so hilarious about your indignant kind of look on your face. Like, yeah, well, I can do stuff. No, you can't. We did this exact question yesterday. This was the question yesterday with the pulley. All I did was replace the pulley with a block that's not rotating. The exact same question. So that's why, you know, all of your, your I don't know what the word like, your pride, it should be in a toilet. It should be eating some humble pie. So 2 mg minus tension equals 2 ma. There's only one force acting on this box. Tension. That's it. So tension equals 3 ma. That's all there is. Add those things together. You get 2 mg. Oops. You get 2 mg equals 5 ma. Look, if that was a quiz, you just all failed. I don't think I have 50% of the room passing. So I'll say I failed. I'll assume the responsibility. Buck stops here. Way to go, Libby. The real question for you guys isn't this question. The real question is, I have a pulley of mass 3m, which is a disc, and it has radius r. What would be the acceleration of this system? It will not be 2/5 g. In fact, will it be more or less than this? Look, second period will actually get this right. So, do you think there'll be more or less than 2/5 g?
less.
Should be less. There's more inertia in the system now. Right. Get to it. I told you what you would have to do yesterday to make this work. But if you don't remember, the only way the pulley can turn is if the tension is different on either side. Right? There has to be an unbalanced torque acting on the pulley, which means the tension on this side, I'll call T2, is going to be different than the tension on this side, which I'll call T3. They have to be different tensions. It's like some of the tension in the string gets used to turn the pulley. So you lose some tension. So I'll wait, because that should be enough for you guys to throw this together based on the notes you took yesterday. But so far, the only thing that's changed is I have a T2 here and a T3 here. So you look at your notes from the pulley yesterday, and see if you can cobble together what's going to happen for the pulley, where the net force equals I alpha. It just cracks me up that the old man can do it so well and the youngins can't. I'm old. I'm surprised there's anything upstairs. And yeah, so there are two tensions acting on the pulley. So there are two torques. Can we agree that T2 is trying to get it to roll this way and T3 is trying to get it to roll that way? Right. Just by the direction of those arrows? That seems obvious to me. You'll have to choose one direction to be positive, one direction to be negative. But it's been chosen for you because we've already kind of established that this way is positive here and this way is positive here. So a rotation in this direction is positive. Right? We have to link all of that up, make sure it's all the same. That means the torque caused by T2 is in the positive direction and the torque caused by T3 is in the negative direction. I will remind you that this is how you calculate torque. Torque arm times size of the force times the angle that it makes with the torque arm. This is the torque arm, the radius of the pulley. So the torque for tension 2 is going to be R times T2 times the sine of 90 degrees. On all pulleys, it's going to be 90 degrees every time. The strings always come off tangent to the pulley. That means that they always hit the radius at a right angle. The only time that will not be true is if it's not a circle. It's not if it's an ellipse, like a weird pulley, like the ones you would find on a compound bow. They will be different. But in this case, circular pulleys are always going to be coming off at a right angle. There's also torque 3. This one is going to be negative. It's in the other direction. Same radius, different tension, still sine of 90 degrees. Those are the two torques. I don't know why that's tough, but apparently it is. Going to add those two together. I'll get RT2 minus RT3 equals I alpha. It's Newton's second law, but for torque. Now, unless you have something to plug in for I, you have to leave I there. We have probably something we can use for I. You're told it's a disk. Because you're told it's a disk, there is a way to get its moment of inertia. I've kind of made that pretty clear. But what the real thing that you need to be aware of is that you've got to use something that will bring this relationship and the relationship we get for the other two masses all together. Right now, if I bring in the other two relationships, I've got 2mg minus T2 equals 2ma, and I've got T3 equals 3ma. So if you're taking notes and all you're doing is writing down what I write on the board, that's why you have trouble, because you don't write anything else down. But write something important down. You want to get the same acceleration for all of these. That's something you have to do. If you want to solve one of these problems, you have to get the same acceleration for all of them. So you'll have to ask a question. And that question has to do with the motion of the objects in your system. Are they all connected in such a way that their motion is all relatable? I think it's obvious that if this goes down a distance x, this moves over a distance x. I think that's obvious. That's how we're able to say that the two A's are the same. But your next question has to do with how much does the pulley turn when the boxes move? Are they linked together in such a way that the amount that the boxes move is directly related to how the pulley turns? That's a question you should ask. I'm not going to say that question 10 times, but for those of you who haven't done this part yet, what are you waiting on? You must already know what to do. But if you didn't know what to do, you need to ask that question. Does the amount that the objects move relate to how much the pulley turns? Can we say that this is true? It's not a hard idea to make. I try to say to you guys, if the pulley turns one rotation, are the boxes going to move a circumference? Is that the amount of string that will unwrap or move across the pulley? If so, then you can use this relationship to decide whether you want it all in terms of the angular or all in terms of the linear. You have to pick one. I'm going to pick linear. So this one, I'm going to change and write RT2 minus RT3 equals I times A over R. That's me taking alpha and solving to put it in terms of A. That way it kind of links up with the other two, which are already in terms of A. We wanted the acceleration of the system. Next, you either leave it in terms of I or you don't. And I'm giving you a hint here. If you don't know what I is, if they don't tell you its shape of the pulley, then collect all the R's with the I. I know you know what that means, so let me help you. This is algebra, and some of you wouldn't think to do this. I'm giving you a huge hint that will help on your AP exam. Collect the R's. Divide both sides by R. Use the commutative property and the associative property to regroup this. Group the R's with the I. Everything here is about the shape of the object, its radius and its moment of inertia. The rest of the stuff is about forces and acceleration. Always group the radius of the object with its moment of inertia. Always. If for no other reason, do you remember the moments of inertia of all of the round things? Do you have them memorized yet? Oh, just that blank look on your face tells me the answer. Look, if you want to make this easier, get them memorized. Because I'm going to talk like you already have them memorized and bulldoze right past you. Do you notice something that all of them share? If you group the R with the moment of inertia, it is likely that it will cancel out in the future. That's why I say to group the R with your moment of inertia. If you don't, then at least you have them together, and it will help for problems when they say, if the moment of inertia is bigger, does this equation support your idea? Remember, they're going to ask questions like that. Your next test, I'm going to ask you questions about that. So if you want to make it easier on yourself, always group the R, the radius of the object that's spinning, with the moment of inertia that you have for your problem. Now, in this problem, I told you it was a disk. That's one of these. And you should know which one it is. Which one is it? Is it A, B, C, or D? It is B. That's right. Right, drop that in. R's cancel. Now, we've made a mistake here. And I don't know that you know what the mistake is. But if you have this, you've made a mistake. And it's an intentional mistake I put in place to see if you're really paying attention. I did it yesterday too. What's the mass of the pulley? That's the mass of the pulley. You need to put 3m there. All of these equations, that m stands for mass. But remember, we have lots of m's just being thrown around. But our pulley is 3m. It's 3 times some value so that they're all proportional to each other. So right here, when I first put it in, I should have put a 3m in. Yep, so it's just 3/2. But it changes the value. It's 3 times more inertia than we have. So let's put that right here. T2 minus T3 equals 3/2 MA. Now they're all in the same M. Do you notice I have a negative T3 and a positive T3? And do you notice I have a negative T2 and a positive T2? This is one of those things where just add the equations up. I'm going to add these three things together. Those are the three equations, the torque equation and the force equation for each mass. And I get 2mg on the left side. And I get 3/2 m plus 2m plus 3m all times a. Now, I see it clearly. I still have the same unbalanced net force, right? It's still the same box hung off the side. It's still the reason the system is accelerating. But I'm noticing there's more inertia. It's no longer 5m over here. It's 5 plus 3/2 m. More inertia means it's going to go slower. Now, you should combine that together and get 13/2. If you want to decimal it, fine. I think that's giving up, but fine. And solve for A. Four thirteenths is less than 2/5. It's slower. I don't know if you know that 4/13 is less than 2/5, but 2/5 is 4/10. So, yeah, I can compare these two and see that it's clearly slower. This is an easy one. This is what an easy one looks like. I know. This is what an easy one looks like, though. Yes, sir. The R cancels out. There. I mean, we collect the R, divide both sides by R, and I get an R squared here. Right? Because I already have an R here. You would not be able to cancel the R's out in this case, because this R is in the denominator and this one's in the numerator over here.